one of those areas where people have a lot of problems. There's just so many things to remember and so many different ways in which you can approach something that it becomes, I won't say overwhelming, but it certainly becomes a challenge. So we're finishing off 7.2 today. There's not many questions, unfortunately, but I can only do the ones that they give me option to ask it. And we are going to do, in particular, we're going to look at integrals, trig integrals that have secants and tans in them. So we spent a lot of time doing sines and cosines and their combination, but now we're going to do secants and tans. And I've restricted the list. I had a bigger list last time, right? Remember that list? And I've just reduced the rest, this list down into things that involve secants and tans, just to make it a little bit easier to focus. And I've added some things. So these are the two main identities that allow us to turn tan squares into secants and secant squares into tans. These will get used today, both of them. I hope you remember, or at least now that I've written it down, it come back to you, that the integral of secant squared is tan. Did you know that? Nope. Hold on a second. Hello? Hello? Sorry about that interruption. It's one of those stupid think robocalls that you answer and there's nothing there. That way they know your telephone number works, and so you get put in a list somewhere. See, so few people know my telephone number that when you phone me, it's normally something important, but not this time. Okay, I'm distracted, so I'm going to have to undistract myself by telling you a story about my mum. My mum was the mother of, obviously, my siblings, all 10 of us. She's passed away now. She made it to 93, which is a pretty good year. And she got smaller the older she got, because, your bones and things shrink down. So when she was really old, she was about just above 5 foot, I think about 5'2". And I don't think, give background to my mum, I don't think I ever heard my mum swear once in my life. My dad, God, he would swear every second word, but my mum totally didn't swear, at least none that I can remember. Can't even remember my mum being angry, even when you were naughty kids. It wasn't so much an anger, she was kind of good at making you feel guilty. So you might think, where am I going with this joke? Well, it's not so much a joke, but it's funny. Towards the end of my life, her life, my mum's hearing was pretty much gone. I mean, if you talked loudly and you were next to her, she could hear you. But telephones were very hit and miss, depends on how good the line was. And one day she picked up the telephone, it rang, she picked it up, and it wasn't a robocall, but one of those calls where they try and sell you house insurance or something, right? One of those ones. And she's on this thing for about, I don't know, 10 minutes saying yes, Didn't hear a word. Yes, and things like that, the kind of noises you make. And at the end of it, she went and said to the guy, I didn't hear a darn word that you said. Could you tell me it all again, please? And the robo guy cop thingy put the phone down. So I was thinking, that is such a good way of dealing with these buggers. So I haven't done it yet, but one day I'm going to get phoned up by, the guy that's selling you life insurance or trying to get your mortgage changed or whatever, right? I'm going to pick that phone up and I'm going to put him on the speaker or whatever, and I'm going to say, yeah, and wait till he's done his whole 15-minute spiel. And then at the end of it, I'm going to say, I wasn't listening to a word you said. Could you repeat it, please? And let them put the phone down. Wouldn't that be a good revenge?
I have two things to say.
Okay.
Somebody told me once that you shouldn't say yes or no to those people because they record you saying yes or no. And so when you go to answer your online or your questions to your bank,
Mhm.
you can answer, they record you saying yes or no. And so that's like that. That's
Ah,
what I heard. That's what I heard. So never say yes or no to them.
uh-huh.
Um,
Okay.
and the second thing I have to say is on the lines of secant, squared, and tangents.
Yes.
Watched. There's this video that you posted.
Uh-huh.
It's the second video,
Uh-huh.
and he has these Roman numeral like rules,
Uh-huh.
and I wrote those down. This is for everyone in class, and
Uh-huh.
super helpful. Like I I already understand the secant tangents.
Cool. Now, this is which particular video so we can send everybody to it? Did it have a title? Was it the second
Yeah,
one in the list or whatever?
I'll go to it was on your page. I'll get
Right.
it. The guy's really nerdy and it's really hard to watch those videos just because he's got a really annoying voice. But these rules that he put out are like they were perfect.
Cool. So I'm trying to think the easiest way to get people to look at that.
I'll find the video.
Yeah,
I'll post
if you
it.
just send me a link to the specific of the video, I can take that single video out and just put it on the Canvas page as a single click deal, and that way you don't need to go hunting for it.
All right.
Will that
And
work?
then just for everyone's, information, like just write down the rules and watch what he does for DU and U. And that's all you need from these videos.
Cool. I like that. Thank you.
And I'm out.
Okay, thank you again. Okay, everyone, so let's look at the combinations of these secants and tans. There are going to be three main situations. Both of them odd, one even and one odd, or an even on its own. There's not going to be an even combination. There could have been an odd on its own combination, but since they didn't give that one, I'm not going to do it. It's not hard to figure it out. So let's look at my first example. Suppose you want to take tangent 5 secant cubed dx. Now, both of these are odd powers, secants and tans. When that happens, choose secant. That's the rule. When they're both odd, choose secant as your u sub. They're all going, 1 and 3 are going to be u subs. So let's see what happens next. If you differentiate secant theta, you get secant tan. Which is what that's saying. If you do the crossover, you get secant tan with a dx. And when you isolate it, you get 1 over secant tan du is equal to dx. Are we all comfortable about if this is the u sub, this is what it turns into? It's pretty mechanical. Right, now, over here. I suggest when you do secants and tans that you just leave everything alone. So don't turn that guy into u cubed yet. So in a way, I'm not going to do anything much except replace the dx. And now I can do a little cancel. 1 secant leaves a square, 1 tangent leaves a 4. So right now we are looking at 2 tangent 4s secant squareds du. So it is still a u sub, but just approaching it a little bit different because that's what you have to do. Now, once you've taken care of the cancelling and you're left with this, now you start replacing people. The secant's going to become u. And I'm taking lots of time with this. Now, what should happen if you do this correctly is that you should have even power of tan here, either tan squared or tan 4. In this case, it's tan to the 4. And we need to figure out how to turn this tan to the power of 4 into secants. So I go over here and I look and I say, tan squared can be written as secant squared minus 1. So won't tan to the 4 be the same thing as tan squared squared? Are we comfortable with that? Now, the reason I'm doing that is so that I can turn it into 1 over secant squared squared. Right? What do you think I'm going to do next? What's going to happen here?
Foiled.
Oh, not quite yet, but that is
Okay,
coming.
yeah.
Right. Before
Yeah.
that happens, what's going to happen? This is going to become 1 take away what?
U squared.
Have you seen that it took us a little, I'm not saying you need every single one of these lines, you probably don't, but can you see that you've now got to the place that you should be with a U sub? Isn't everything in use? Now, someone said foil, I totally agree with you.
Quick question.
Yes.
On the page on the left, it says tan squared equals secant squared minus 1. But then on the right,
Oh,
you said...
yeah. I got tan squared and I... How do you fix it? How do you fix it? -1 plus 1, -1 plus 1, -1 plus 1. Fixed! So what's that going to get me? -1 plus that guy squared. That's going to get me 1. -2 then plus U4. Thanks. I made a mistake there. I should have used the tan squared secant squared minus 1 guy. Okay. So that's what happened here and here, but kind of fixed it. Distribute now. 2u squared, take away 4u to the 4 plus 2u to the 6 du. Right, with the little hiccup there. We're good. We're pretty close to finishing, aren't we? Power rule everywhere. 2/3 u cubed, 4/3 u to the 5, 2/7 u to the 7 plus some c. Turn all the u's into secants. If you're doing notes, you could probably just put ... here and leave 4 or 5 lines and you could fill it in your own time. Are we comfortable about when it's an odd and an even, the generic process, not just this particular one, but how you would tackle it in similar circumstances? If both powers are odd, use secant and you get this. Leave them alone, just turn the dx into this guy. When you cancel it out, there should be even powers of tangent and secants. The secants get converted straight into u squareds. The even powers of tan get turned into secant squared minus 1s. That's what should be there. But -1 plus secant squared is the same thing. That then turns into u squared. Distribute until you can distribute no more. Power rule. And finally, once you've multiplied all this together and got this guy and done the power rule, convert them back into secants. Ugly answer, isn't it? You can't really do much with it, but it is what it is. Are we okay with our first situation then? What to do when you do tans and secants and both are odd powers? This is basically our template, but not a lot's going to change. there's not an awful lot of permutations they can give before the question becomes impractical. Yeah, you're not going to get tan to the 99x secant to the 95th x. You know, if somebody done that for you, wouldn't you be spending the next 2 weeks just writing down a huge thing this size? So you know they're going to keep to single 3-5, single 3-5, you know, that kind of combination. And that takes us to the both odd. Right, now in no particular order, I have gone even on its own, and I have an even and odd combination. So which one do you want to look at next? Which situation do you want me to do?
Even and odd.
Okay, so we'll look at number 3. And in this case, you've got an odd power of tans and an even power of secants. And when you have that combination, you're going to use a u sub, and you're going to use tan theta, and then you're going to do conversions to finish with. What's the derivative of a tangent? Derivative of a tangent theta.
Secant squared theta?
Yes. So crossover and isolate. Did I just do tan? I did. Just confusing the heck out of myself. So let's see what we have. We have a 2 tangent cube theta secant to the 6 theta, and replace the d theta by this guy. When it's secants and tans, I try and leave this thing alone because you're never quite sure what's going to cancel out, and if you do a substitution too early, you might not notice it. I think in this case, it didn't really matter, which is fine. Cancel, cancel, 4 behind. Okay, now at this point, shouldn't we try and turn everybody into a version of tan theta, right? So we can turn everybody into a u. Would you agree that this fella here is a u cubed? Right, tan cubed, u cubed. How do you think I'm going to deal with secant squared theta, bearing in mind that I want tangents, not secants? Is there anybody over here that can help me take care of the secant thing?
Change it into 2 sets of tan squared plus 1.
Okay, so I've skipped a line there. Wouldn't this line be secant squared theta all squared? Just cutting down on my workload. Now, if you do that, you get a u squared plus 1 squared. Everybody happy about that one? If you then look at this fella, you get u to the 4 plus 2u squared plus 1. And then distribute it a little bit more. I'm going to stop here. Would you agree that's just going to be a really ugly power rule like all of them are? Right, add 1 to the power, divide by new power, add 1 to the power all the way through. And then once I've done that, turn everybody into tan theta. And that u sub, question.
Should it be 4u to the 5th?
4u to the 5th. Yes. Thank you. Well, the fact you picked up means you know what's going on. Are you comfortable with that process of, you know, who you pick? Now, I'm not breaking the rules here or the choices that I make, but in some circumstances, secant theta will also work. In this case, a u sub of secant theta would work. So if you're doing a combination of secants and tans, right, you've got a lot more flexibility in situations. A good chunk of the questions, either secant theta and or tan theta will both work, right? Making up an order, about at least half of them, if not more. And then it's only the other half that you need to be a little bit more careful about. Are we cool with that guy? Secant, tan, even. If you come across a question where u equals secant theta doesn't work, won't u equal tan theta will work. It's not like you have 100 choices, right? You only have 2, so if one of them, you know, isn't working, then it just means pick the other one. Well, we've got a last guy to tackle. Actually, keep the best till last. Here's an example of both situations. I mean, tan squared on its own, secant squared on its own, right? Special case. Let me show you this one. The integral of secant is tan. I should say it again. The integral of secant squared is tan. That wasn't hard. Agreed? Now, what about tan squared? Nothing. I don't have one here. Any suggestions for what I might be able to do then if I don't know how to integrate tan squared, what I might do? And don't think u subs. Don't even go there. It doesn't help.
Just change it to
Okay.
secant minus 1.
So take tan squared and turn it into secant squared minus 1 guy. And multiply it out a little bit. Make it a little bit easier to see what you're doing. And won't 4 secant squared get you 4 tans? And won't the number -4 get you that guy? Well, they're really nice and nothing too much to deal with. Are we good? Any questions before I call this, you know, stick a fork in it and call it done? Okay. New section. I believe it's called trig substitution. I don't like that name because it really doesn't come across. I like to call these guys X subs. And you're going to find out why that name, in my opinion, works better. All I'm doing right now is getting these guys all sorted out. If I can find the right place to click. Oh, I've been timed out. I'll have to go back in from scratch. Almost there. Almost ready. It is called trig sub. I thought that's what it was called. That's its heading, I think, in the textbook. Right. And as you know, I'm drifting all over the place with my brain. Something just came to me. I'll share it with you. There is now a new member to our family back home in Scotland. Had a new baby in the family. She's called Daisy. Very pretty little girl, 8 pounds. Which makes me a great granduncle. But if you're in my family, we all know about you. So everybody, Facebook's great. So we all got the same photographs. My nephew's daughter had a daughter, so I think I got the right number of greats in that. So just thought I'd share that. I was over in the restaurant and I was looking at the picture, and the woman was asking, says, "It's a new baby at the family," and she said, "And what's its name?" And I said, "It was Daisy." And she said, "Oh, and what's its middle name?" And I had to explain to her that we don't have middle names typically in Scotland. We just have your name and your last name, whereas in America it's more a tradition. I'll share some more stuff with you. My name is Donald. You know that. What you might not know is that within my family and within some of the older families, it's not so true about the later ones. That's why her name is Daisy. There's a convention about how you name your children, and it's quite precise. Your first boy is called after your dad. So whatever your dad's name is, your first boy has that name. And remember, we don't have middle names, so that's his name. And the first girl is called after your mum. So in my family, my dad was called William, so his first son is called William. And Margaret was my mum's name. There's wiggle room for that. So her first daughter was called Peril. On her thing, she's called Margaret, but we call her Peril. Peril's Gaelic for Margaret, in case you're wondering, because it's the same name. After that, all the boys or girls that get born get named after brothers or sisters of your dad or your mum. In other words, your uncles and aunts. So I'm called Donald. I'm after my uncle Donald, which was my dad's brother, called Donald. My uncle Donald had a son. Do you know what his son's first name was? Donald. So when we have weddings, there's a lot of Donalds. Just to show you, do you know how some Americans have names like Frederick Smith the Fourth, something like that? It's like a number at the end, and they're quite proud about it. That'd be pointless in Scotland, because my dad, I'll give you an example. My dad is William, right? My dad's called after his dad, my grandfather, William Robertson, whose father, by coincidence, happened to be the oldest son, who's called William Robertson. My brother Billy is William, his son is William, his son is William. If you were going to start numbering him, he would be William Robertson the 23rd or something stupid. So nobody in Scotland is pretentious enough to stick a number after their name. But evidently Americans think it's important, so maybe it makes them feel old. But within my generation, can you imagine a wedding at our family when somebody says, "Hey Donald," how many turn around? Just to name a few. Right, you can tell I'm getting homesick. Sorry for inflicting that on you, but if I didn't do it, it would just distract the heck out of me anyway. So we're going to look at trig substitution. And let me tell you what it's not. You probably think you've already done trig substitution, which you have. You know, the ones where u equals sine x and v equals, and u equals tan x, that kind of stuff. That is trig substitution, which is why I don't like that name. They should have called that section trig substitution, because that's essentially, for most of them, right? That's what you did. Now, this thing is for finding integrals that don't even have sines and cosines in them. Let me show you an example of what that would look like. That is the type of integral that you're going to deal with in 7.3. When you look at that, that doesn't even vaguely look like it's got anything to do with sines or cosines or secants or tangents. Would you agree? Doesn't even vaguely look like it. And yet it is. But we don't do a u sub. We do an x sub. And we say, in this case, let x equal 2 tan. Oops. Let me get this guy sorted out. There we go. Let x equal 2 tan theta. Now, normally you do a u sub, u as a function of x. You don't, or u as a function of theta, right? You don't do x as a function of theta, but this is what you do. And there's rules about which one of the three that you're going to use. There is some multiple of sine theta. There's some multiple of tan theta. And the third situation, there's going to be some multiple of secant theta. One of those three is your x sub. And there's rules about it that we'll talk about another day about how you decide. It'd be really nice if they just told you in the question, you know, use this. But I can show you how you find out later. Let's just assume then that this is a good x sub to use. So it's looks very similar, and we're going to do very similar things. I am going to differentiate x with respect to theta. Okay, what is 2 tan theta's derivative then? What'd you get if you differentiate 2 tan theta? I'll bring my little list out for you.
2 secant squared.
Right, that guy there. Now you do the crossover. Except when you do x subs, you only need 3 lines instead of the typical 4. Because what I've now got is, don't I have dx in terms of thetas? And I'm going to go and replace every single x that you see here, including the dx, with something with thetas in it. So let's see what that would look like. 1 over x squared becomes 2 tan theta squared. The square root of x squared becomes 2 tan theta squared add 4. The dx is going to become 2 secant squared theta d theta. It's very similar to u subs. Haven't we turned the integral from using x's to using thetas? Now let's see what happens next. I'm going to have 2 secant theta on the top. I like to stick the d theta over here. That guy is going to become 4 tan squared theta. And this fella in the square root is also going to be 4 tan squared theta add 4. And you really do need to be aware of what the heck is going on here, right? 4 tan squared theta plus 4. The guy inside the square root, if you do it correctly, will always turn into something nice. I'm not going to cancel anything right now. We'll do that later. I just want to take it one small step at a time. I need to find out what this simplifies down to. Show you how I would tackle it. Pull out the common factor of 4. Do you recognize tan squared theta plus 1? Because it's over here. What's tan squared theta plus 1?
Secant squared.
Mm-hmm.
And nicer than that, aren't these perfect squares so you can get rid of the square root? So this guy just became 2 secant thetas d theta. So you start off with some ugly x's, especially a square root. There's always going to be a square root in these questions typically, right? You do an x sub of 2 tan theta because I told you to. You replace everything that's in x or a dx in terms of theta, and then you make it look pretty. And what could I do next? Anything I can do to make this prettier? Cancel, for instance.
Cancel the secant.
Right, so secant with that leaves me a secant behind. Oh, can I cancel the 2's while I'm at it? Okay, so now we are going to be left with a secant theta on the top and 4 tan square thetas on the bottom. Now, what you get left with is quite random. All sorts of weird combinations happen, right? This is what happened in this particular question, right? I have a secant theta on the top and 4 tan square theta on the bottom. And I have to, or we have to figure out how we're going to deal with integrating that. Any suggestions for what to do here? I'll tell you right now, a U sub won't work right now.
I would split up the tangents into tangent times tangent, turn one of those tangents into a sine over a cosine, turn secant into a 1 over cosine, and then
See what happens.
Cancel out the 2 cosines.
Okay, let me do a kind of adaptation of what you just said. Isn't that the secant on the top? Right, I've written it as 1 over cosine. I'm not going to split the tan. I'm going to call it sine squared over cos squared. Okay. Now, if you get a combinations of secants and tans or sines and cosines that aren't the typical way that you're looking at them, it's a good idea to try and rearrange them. And in particular, secants and tans should be turned into sines and cosines, right? Always look at that. If you've got sines and cosines and that's all you've got, you're probably already at the point where a U sub might happen. So you can see these are big questions, right? You don't get many in a dozen. This ugly mess here is going to be rewritten a little bit differently. Top fraction divided by bottom fraction. Can't that be turned into top fraction multiplied by reciprocal of bottom fraction? Are you happy about this becomes that? Because there's another way I can show you to deal with that if you don't like this one. Right. Fractions can be thought of as divisions, right? Guy in the top being divided by guy in the bottom. Guy in the top, divided, reciprocal, turn upside down. Now, if you do it this way, a cosine cancels, and now you have got that. And that's normally a good strategy. Turn everybody into sines and cosines. Now, these questions are horrendously big, and although I've got 7 minutes left, I'll need it just to finish this question, because there's a long way still to go. Oh, side issue. If you didn't like how this became that, let me show you a different way in how this will become that. I have, well, let me rewrite that. I don't need the integral, it's a distraction anyway. I want to find out how to make that look different. I'm going to multiply top and bottom by cosine squared. 1 over cosine times a cosine squared gets me a cosine. This fraction times a cosine squared gets me 4 sine squared. Do you see I get the same answer, but a different way of looking at it? Okay, you might like that way, you might like this way. I don't really care because both are valid. Okay, we are back to this fella. And here's a U sub. What's the U sub going to be in this question? Who shall I pick as my U sub?
Sine theta.
Agreed. Have you noticed that when you deal with most sine cosine combinations, isn't it a U sub sine theta on its own or cosine theta on its own? Isn't it very rare that you do a U sub of a sine squared or a cos squared or something, right? It won't say it won't happen because everything will happen once somewhere, but in general, single guy does. So we're now differentiating to get cosine. Cross over and isolate. Good grief. So what do I have? I have cosine theta for sine squared theta replaced by a 1 over cosine theta du. Cosines cancel. I have a 1 over sine squared. I guess I should have done that a little earlier, but I've got it now. God, that took a lot of work to get to here. I mean, it started life as an ugly square root. It became just as ugly, or maybe a little bit less ugly, trig with theta. And now it's became this guy. I'm going to call that 1/4 u to the negative of 2. Why am I calling it that fella?
The 1/4 is a constant. You can take it out.
Yeah, and why the negative 2 part? You're right. Yeah, power rule. So add 1 to the power, divide by the new power. Negative 1 over 4u. Agreed? Now you might think, well, where am I going here? Because it's hard to keep track. I'll tell you where I'm going. I'm eventually going to tell you the answer in terms of x's. Right now I've got the answer in terms of u. Can't I then use u as sine theta to get the answer as 1 over 4 sine theta plus c? So are we cool about that? That this becomes that. The u sub is sine theta, so that's negative 4 over sine theta. And now I need to turn it into x's. In this question, we started, and darn if I can find it now. Oh, here we are. We started with x is equal to 2 tan theta. Somehow that is going to allow me to convert this into x's. Now, it does not look very promising, and that's because this is a brand new trick. You've never seen this before. I'm going to show you how you can take this algebra expression and use it to find out what sine theta is equal to. In this case, sine theta. So, first thing you do is you isolate what tan theta should be on its own. And then I'm going to use a guy called SOHCAHTOA. Can you remember SOHCAHTOA? What is the ratio for a tangent using SOHCAHTOA?
Opposite over adjacent.
So opposite on the top, right, over adjacent on the bottom. Now, that means the x is the opposite and that the adjacent is 2 and that the angle is theta. So what I'm now going to do is construct a right angled triangle where I'm going to call this angle theta, and I'm going to use SOHCAHTOA to name the other three sides: opposite, adjacent, and hypotenuse. And since I know that the tangent is x over 2, I know that x goes here and 2 goes there. So far, so good. Now, how will I be able to find the third side in terms of x? Come on, we got 2 minutes. How will I find the third side in terms of x?
Pythagorean theorem.
Correct. And won't it be x squared plus 2 squared, which is 4? Now, you won't know this until you get to here, but this is a really good sign. Do you see this weird square root? He better be that weird square root. See this one here? He better be him. If he's not him, you've just spent 20 minutes and screwed up somewhere.
Or like an hour. Jeez Louise.
Or an hour. So you want to see this guy, right? I don't care which side he's on, right? Because sometimes he's on the opposite, sometimes he's in the adjacent. But there will be this ugly square root, and he will be here. Well, we are pretty close to getting finished. Don't I need to know what sine theta is first? Let's not do too much in one go. So I want to know what this fella is. According to SOHCAHTOA, yet again, isn't the sine the opposite over the hypotenuse? So the sine of theta will be x over the square root of x squared plus 4. So this will be -1 over 4 times that guy plus c. One line and we are finished. There must be a better way of writing this ugly fraction, agreed? Isn't 1 over something just its reciprocal? So this guy is -1/4 and we are finished. And I went